Hi there. Welcome to our Bio24 lecture on vaccines. First, let's briefly talk about what vaccines are. When we talk about human immunity, there are two different categories. There's natural immunity, which you can get from nature, of course, without modern medicine. And then there's artificial immunity, which requires modern medicine. Within those categories, there's active immunity and passive immunity. Active immunity is when your own body's immune system is stimulated by a foreign agent. When the body's immune system is stimulated by that foreign agent, it learns from that experience and becomes stronger in the process. Passive immunity helps the immune system function better, but that help only lasts temporarily and does not last for the lifetime of the individual. So it's helpful now, but in the long term, it does nothing to the immune system. In the natural world, active immunity is getting sick. When you get sick, your body learns from that interaction and becomes stronger as a result. Passive immunity in the natural world really only happens with breast milk. And this is when a mother breastfeeds her infant to provide her infant with antibodies or molecules of the immune system. Now, in modern medicine, we've been able to take these lessons and apply them to the advantage of the patient. Now, in modern medicine, active immunity is vaccines. This is using a foreign agent in order to stimulate the immune system and get the immune system to recognize this foreign agent again later, making the immune system stronger in the process. The difference between active artificial immunity, vaccines, and active natural immunity, getting sick, is pathogenicity or causing disease. There'd be no reason to give vaccines if vaccines cause disease like the natural illness would. Instead, the whole idea behind vaccines is they are not pathogenic in that they don't get you sick, while still being antigenic in that they're training the immune system. Getting sick is pathogenic and antigenic at the same time. It makes you ill, and in some cases can kill people, but it can, if you survive, stimulate the immune system, whereas vaccines just stimulate the immune system without getting you sick. Passive immunity that you see here, this is more like antivenin or antitoxins. They provide assistance to your immune system at the time in order to help you overcome a current infection that you have. That is considered immunotherapy, not vaccines. And this is usually provided to individuals who are already sick or have a compromised immune system that doesn't function properly. Vaccines have been around for a very, very long time. And I briefly want to cover the history of vaccines. Over 200 years ago, in the late 1700s, Edward Jenner was credited with being the first individual to provide and develop the first vaccine. He provided this vaccine in response to smallpox. Many doctors at the time knew and recognized that dairymaids had beautiful milky white skin, unscarred by the smallpox disease that seemed to affect every other individual in the population. No one really understood exactly why, and some people had hypothesized that perhaps it was because dairymaids would occasionally contract cowpox by milking the udder of sick cows that were infected with pustules on their udders. When asked, the dairymaids would always reply that they never got smallpox, but that at some point in the past, by milking the dairy cows, they had acquired cowpox and got a few pustules perhaps on their hands, but it was nowhere near as debilitating as the smallpox disease itself. Everyone else in the population at the time got smallpox. It was essentially a matter of fact that as individuals were growing up in Europe, as children, most often, they would contract smallpox, and 1 out of 3 would end up dying from the disease. Those who survived would have lifelong immunity and never get smallpox again, but they would end up having scars on their hands, feet, and face where smallpox liked to generate pustules, usually on the extremities. This is partly the reason why wealthy people at the time ended up putting plaster makeup all over their skin to hide those scars. But the dairymaids didn't have to do any of this, and Edward Jenner, recognizing this, thought perhaps it was the cowpox that was providing the dairymaids with protection. He needed to try this hypothesis out on an individual that had never had smallpox before. Of course, the only individuals at that time were young children. So he ended up asking his gardener if he could borrow his gardener's child. The gardener initially said no, but upon promise of a small cottage on Edward Jenner's land, the gardener decided that it would be okay for Edward Jenner to try out his hypothesis on his kid. And so Edward Jenner ended up scraping the arm of the child that had not had smallpox yet and applied a little dose of the pus from the pustules of a cow with cowpox. Here was the key. Edward Jenner ended up allowing that child to go off and play for a few weeks and allowed the cowpox to train that child's immune system to recognize these pox viruses. He needed to give that child's immune system that time. After a few weeks, the child came back and Edward Jenner actually placed smallpox pus onto the child's other arm. The child never contracted smallpox. Then to confirm this, Edward Jenner tried this again and tried putting smallpox onto the child's arm 6 months later. The child was still healthy and did not contract smallpox. After the word got around, more families tried this experiment with their children as well, allowing Edward Jenner to run this experiment on their children. And the more children it was experimented on, the more recognized it became that cowpox was actually a way to protect against this deadly disease of smallpox. This is why vaccines are called vaccines, because vacca means cow in Latin. And this was the very first vaccine to be generated. This was over 200 years ago, and we still are manufacturing and researching new vaccines today. But we don't have to manufacture smallpox vaccines extensively anymore. And the reason for this is that as a result of worldwide vaccination, smallpox, which only infects humans, again, we're not talking about cowpox here, we're talking about smallpox. Because smallpox only infects humans, the World Health Organization ended up vaccinating enough people around the world that no one contracts smallpox anymore. It is thus considered completely eradicated for the last 40 years and is the first disease completely eradicated from human existence. Quite an accomplishment for the World Health Organization, especially considering how many millions of lives smallpox would take prior to its eradication. Today, vaccine preparation is much more precise and scientific, creating a much safer product. Most vaccine designs are based on one of 3 methods, and there's a 4th method we're going to talk about that involves new biotechnology. These methods are listed here. Now, the first one listed here is killed cells or inactivated viral particles. Killed cells are the same thing as inactivated viruses. Because viruses are not considered alive, we can't say that we've killed them. The proper term for that is inactivation. So a killed cell is the same thing as an inactivated virus. Essentially, you're destroying them. The way that you make these is you would grow the pathogen in a lab, and of course this would require biohazardous safety levels to make sure that there's no contamination of lab workers. Then you would have to kill or destroy these cells or viruses, making sure that as you do so, you don't change any of the molecular properties so as to make sure that the immune system can still recognize the living pathogen when it encounters it. Examples of viruses that are produced this way is hepatitis A vaccines, the flu shot, the polio shot, which most people don't get these days. We'll talk a little bit about why that is later. And also rabies vaccines. And most people don't get the rabies vaccine today either, and that's because rabies is so rare that it's considered unnecessary to provide it as a vaccine to the general population. These vaccines often require larger doses or booster shots, such as in hepatitis A. And the reason for that is because when you're injected with these cells or viruses, that's the only dose that you get. These cells and viruses don't replicate inside your body, and so usually the dose is relatively small compared to your immune system. So to properly train your immune system, you usually need a larger dose or booster shots in order to really train your immune system to recognize the pathogen well. The second category that's listed here also includes whole cells, but in this case, the cells or viruses are alive or active. So they can replicate inside your body and cause an infection, but again, the whole idea is that they do not cause disease. This category is what's referred to as attenuated cells or viruses. Attenuated means weakened. If they weren't attenuated, then they would just be the pathogen. You'd essentially be injecting people with the pathogen. And of course, that's not the point in vaccines. The point in vaccines is to train your immune system without getting you sick. So when we say attenuated, what we really mean is that they're weakened to the point where they do not cause disease anymore, although they can replicate inside your body still. Examples of these are the MMR, measles, mumps, rubella vaccine, smallpox vaccine, which again, like I said, we don't use anymore, except for people in the military. Oral polio, which are drops that you take orally, or you swallow them, the chickenpox vaccine, the yellow fever vaccine, and also that nasal flu spray if you get the flu vaccine by a nasal spray. The way that these are produced is often that the pathogen is grown in a lab but under slightly stressed growing conditions, so that the pathogen is not able to grow optimally, and in being stressed out while it's growing, it loses its ability to cause disease. It becomes weakened. Modern versions of these, however, include pathogens that have mutations in them so that they can no longer cause disease at all. These often require fewer doses or booster shots than other types of vaccines because the virus or bacterium can replicate inside your body, so you don't need as much initial dose. They do, however, require special storage facilities because these are living or active pathogens. And so you need to make sure that however you store them does not kill them in the process. Sometimes these are stored in a refrigerator or special conditions. They also have very early expiration dates as well. Another interesting side note to these is that they can be transmitted to other people, which could be a good thing if those other individuals want to be vaccinated as well. We'll talk about the other options later.